Welcome to Stellartive STEM class. We are going to look at this concept. People used to ask electricity generation from the power station or the source of electricity to our homes. How does it travel? So these are some common questions people used to ask. Why do power stations transmit electricity at very high voltage and we use them at home? Why? If electricity travels hundreds of miles from a power plant to your home, why doesn't it run out of energy along the way? People ask. Electricity can travel from so many thousands of kilometers to our home. Why? Or one power source can distribute electricity to a whole country, travel to so many thousands of miles. Why doesn't it finish? These are questions I want us to watch, and I will teach you something small about it. Why are power transmission wires suspended high above the ground on a tall tower? You can observe from the diagram that these towers carry very high voltage at very tall and at an equidistance from each other. Very tight. Why does this happen? Let's go. Let's look at the next slides. Now, look what is AC. Electricity transmission. An alternating current is a form of electricity that commonly used for transmitting electrical power over a long distance. AC, that's alternating current power travel from a very long distance. The power station generates electricity, which is in turn, which then transmit high voltage power lines to our homes and goods. So this power station transmits electricity from very long distance, from one point to another distance, to sometimes to entire country. So they travel across the whole country. And why does this happen? Now let's have a look at this. Look at a sample example of how that this happen. This may be from a power plant. You can see the diagram. This is a power plant. This is a step-up transformer. It raises step-up means it raises the voltage, maybe about 1,000 watts. So this is the high tower, where the cable passes as very high. You can observe a distance from there from the ground, and it travels far away. When it comes to the substations where it is stepped down, so from here it moves straight to another power distribution substation now to our homes. So why does this happen? Let's have a look at this short video and see the reason explained, and I'll come and explain why does this happen. Let's watch this video.
I've always wondered why you have to get so many high voltage lines. You take the power from a power plant, raise it to hundreds of thousands of volts through a transformer, and then lower it down through a transformer when it reaches the user's area. Isn't that redundant? Today, I finally realized that high voltage transmission is really beneficial, because the process of power transmission from the power plant to the user is usually a long distance. But the wires have resistance. This causes power loss, and the loss is proportional to the square of the current. The formula is as follows. If you want to reduce the loss, you must reduce the current. But power is equal to voltage times current. So if you want to transmit the same amount of power, the current must be reduced, and the voltage must be increased accordingly. In this way, the transmission over long distances does not lead to significant energy losses, thus increasing the efficiency of the transmission. In addition, because the current is reduced, the cross-sectional area of the wire required to carry the current can be reduced. This reduces the use of wire materials and lowers costs, which plays a key role in the transformer and what is the principle. In fact, to put it simply, is the use of Faraday's law of electromagnetic induction. That is, electricity generates magnetism.